Hey guys, Terry here. It's time for us to start turning our attention to how RIP operates in a non-broadcast multi-access environment. Now I'm going to return us to our presentation because what I'm going to do is I'm going to modify this. We're going to add some devices. The devices that we're going to add are going to be representative of, let me go ahead and just grab a smaller eraser here. They're going to be representative of 3 remote offices. So what we'll do is we'll do remote office blue. Remote office blue is going to be the router. Let me fix that. I keep drawing slightly off of the board. I apologize for that. So we have office blue. Now later on we'll play around with VRFs, but the main idea is that this is going to be R19. We're also going to have Office Red, which is going to be R20. And lastly, we will have Office Green, which will be R21. Now, what I want to point out here is these devices are interconnected to our infrastructure via a cloud. So via a service provider network, these devices are connected to us. In fact, inside of the service provider cloud is a router referred to as ISP4, Internet Service Provider Router 4. And it's going to be a router that we don't have any influence over. We can't do any manipulations to it. But at this particular juncture of our conversation, that's not important. What's important is for us to recognize that we have the capability of running a number of solutions in order to get our infrastructure up and operational. And one of those solutions is going to be the idea of executing a routing protocol across what's referred to as a DMVPN topology, a dynamic multi-point VPN. Now what I want to do is I want to illustrate this. So what I'm going to do is I'm going to go to R21, or R19, excuse me. And on R19, what I'm going to do is I'm going to highlight some information, and we're going to annotate that information on our whiteboard here. So first is the address range. Well, show IP interface brief is going to give me, exclude assigned addresses, it's going to give me a tunnel designation. That tunnel is going to be in the network of 10.10.10.0/24. So the network that I'm working with here in my drawing is going to be 10.10.10.0/24, where this is going to be .21, this will be .20, this will be .19, and again this one will be .5. Now notice we're using tunnel interfaces. So I have tunnel 0. So these are going to be the tunnels that I'm using to create my DMVPN. Now what I want to do is I'm going to make certain that we run a routing protocol across these tunnels. So what we'll do is let's go over to R19 and do the basic configuration just like we did in the other devices. So again, it's going to be config T, router, RIP, version 2, no auto this time because we've already explored no auto summarization. And I want to advertise the network of 10.0.0.0 and network 172.16.0.0. Exit, exit. Let's cut over to 20 and do the same thing. Network 10.0.0.0.0 and network 172.16.0.0. And let me grab an eraser and take off all of this garbage right here. All right. Okay. And lastly, let's do R21. Config T, router, RIP, version 2, no auto, network 10.0.0.0 and network 172.16.0.0. All right, let's take a look at this. Now I want to do my investigations initially on R5. Show IP route RIP And let's see what prefixes we're learning. If I'm learning my prefixes right, I should have 16, 21, 20, and 19 in my routing table. Notice they're being learned via RIP, and notice that they're coming across this tunnel. Well, this tunnel is a multi-point GRE tunnel running Next Hop Resolution Protocol, which defines a DMVPN topology. So when I go over and I start taking a look at this, just to verify that we have the spoke-to-spoke reachability, what I'm going to do is I'm going to see that we have the capability of being able to send information, but what we're going to find out is this is going to be a Phase 1 DMVPN. Phase 1 DMVPN is just a pure hub and spoke. There is no dynamic spoke-to-spoke communication. So in order for spoke A to talk to spoke B, we have to do it by transiting all of our data through the hub. Very similar to what we did in a frame relay environment where we are going to be operating in a pure hub and spoke. So that's basically all we're doing, is we're highlighting that point. So from here on R5, can I ping 10.10.10.19, 20, and 21? Yes, I can. So let's go over to 19, ping 10, 10, 10, 5. Can I ping 20? And can I ping 21? Yes. Now, let's do a trace route to 10, 10, 10, 21. Notice it's going to 5 and then bouncing down to its given destination. And that's going to happen every time because this is a Phase 1 DMVPN. It's not until we do spoke-to-spoke connectivity with the Phase 2 that we're going to be able to send information directly between our spokes. The important thing to understand is the very, very first packet of every flow will always go to the hub, because that's going to be how we're going to negotiate this dynamic creation of links between our spokes. But we'll talk about that in the confines of DMVPN when we do our configurations for our virtual private network configurations, which is going to be a standalone topic inside the context of the lab. However, I'm going to try to expose us to DMVPN with every routing protocol that we have to work with, both an IPv4 and an IPv6, in order to ensure that we're familiar with its operation well before we ever get to VPNs. Now, looking at this, I see, or should be able to verify my reachability, which I thought I already did that. No, I didn't. So let's do this. Ping 172.16.19.19. Ping 20.20. Ping 21.21. Now, when we go in and we look at this, that means I have reachability to just about everywhere. So if I cut over to 22, R22, the data center, can I ping 172.16.19.19? Well, that's interesting. So this tells me that I can't ping it. Let's take a look at this. Show IP route. RIP. Are they in my routing table? 16, 19, 20, and 21. They're in my routing table. Let's see how far they get. Trace route to 172.16.19.19. Well, we got to 5 and something crapped out. So we're following it. Let's go ahead and just do a drawing here, just one to track it through. So we're going to 3. So we're going to R3. From R3, we're going down to 12. From 12, we're going to 5. From 5, we're dying. Now, we know that we had reachability on that interface on R5. So let's take a look and see what's going on here. All right, first of all, let me go ahead and clear off some of this chicken scratch. And then we'll dive back into our config. So, break that. And now let's take a look again. Let's see. Do I still have reachability here? Can I ping 1919? Can I ping 2020? And 2121? Yes, I can. Can I ping 10.1.2.2.3.2.2.2? Yes, I can. So I've got reachability from R5 all the way back to R22. But when we start looking at this, what we need to realize here is that we may have issues on our remote sites. So let's go to the Office Blue and say show IP route. Well, when we look at the show IP route, we see a lot of information. Notice we have 1919, that's us physically connected. But let's take a look and see what we see with IP route RIP. We're not seeing anything with IP route RIP. Now that's very interesting. So the question is why aren't we learning any information? So show IP route gives me EIGRP, which we're currently not studying, connected, my local interfaces, and that's it. So the question is can I even ping 172.16.5.5? And I can't. So let's take a look and see what's happening. Let's go over to R5 and let's make sure that we didn't fat finger anything. Show IP protocols. Okay, now I'm going to, let's see, do I really want to do that? I'm going to just move over. No, we'll leave it the way it is and we'll just sort through it. Okay, here's my RIP. Now notice here it tells me automatic summarization is not in effect. It tells me I'm running on tunnel 0, I'm running on loopback 0, I'm running on serial 0, I'm running on Ethernet 1, and I'm running on Ethernet 00. But also, let's take a look at what's happening with this other routing protocol. I have EIGRP running on this particular device, EIGRP Autonomous System 400, and we're going to talk about EIGRP shortly, but what I want to highlight here is the fact that it's running on the links for 10.1.145.5, but I'm not learning anything. So the question is, show IP EIGRP or show IP route EIGRP. All right, well, I'm learning prefixes 10.1.194, 10.1.204, 10.1.214, and these are all showing up in my routing table as EIGRP prefixes. Now, the reason that I'm doing this is I'm trying to illustrate the fact that, one, our system will not necessarily always use the same routing protocol on the same interfaces. But the problem here is the fact that RIP is so non-granular, it's very difficult for us to be able to exchange information with regard to what's happening on our infrastructure. So the point here is that I should be learning information from my physical interface. I should be learning something from, not my physical interface, from my tunnel interface about my neighbors. Well, we saw that we have reachability through the infrastructure, but the point here is that I should be able to form some kind of exchange between my spokes and my hub. I'm not even seeing that right now. So let's just take a look at it and see if it's something with regard to maybe just waiting. So show IP route RIP. I'm not learning any prefixes whatsoever in this instance. Well, I know at the very minimum I should be learning something from R5. So again, let's go back over to R5. Show IP route RIP. So notice right here, I see the fact that I'm learning about 162.11. Here's my 3 right here. These are the 3 that I'm learning prefixes for, and I'm learning them via my tunnel. And the thing here is notice that my next hop is to the individual device. So let's take a look and see what happens now. Show IP route 10.10.10.21. How do I reach that interface? Well, it's connected, so it's via a connected interface, and it's connected via tunnel 0. Now, when I look at this, what's happening here is I'm not learning any prefixes from any of my other neighbors, R20 or R21. Now, let's take a look at this. Config T, interface, tunnel 0. No IP, split horizon, and let's see if that makes a change. So do clear IP route star. Now what is split horizon? Split horizon is the rule that the majority of our distance vector routing protocols have had as a default setting for years. What it means is that if I learn a prefix in an interface, I'm not going to advertise that prefix back out that interface. This is a very, very simple and rudimentary loop prevention mechanism. And it's on by default in RIP version 2 as it's deployed in our 15 code. Now let's see if this fixed our problem, because this may not be the only problem that we have, but let's see what happens. So exit, show IP route. Show IP route RIP. Well, notice I'm still not learning anything here. So let's go back to R5 and see what's going on. Is the link back up? Show IP route. Still have it as a routing RIP interface, tunnel 0, tunnel 0, tunnel 0. Do I still have reachability? Ping 172.16.19.19. Yes, but what happens if I source it from another interface? So let's source it from E00. I'm not learning anything via that interface. So the question now is why isn't this working? So, I mean, I know I'm not advertising any of these prefixes to R19, R20, and R21, which is why it's not working. But the question is why am I not advertising any information out that link? So it's a very interesting scenario. It's a pretty significant conundrum. Show IP route, RIP, show IP route EIGRP. Well, the only thing that I'm learning via EIGRP are about the interfaces that I want to learn on. So that's going to be 44, 19.4, 24, and 21.4. So my next hop, so show IP route 10, 10, 10, 19, my next hop is going to be via my tunnel. So let's take a look here. Show IP protocols. Well, let's see, we're running the gateway, routing information sources 20, 21, 4, and 12. My default distance is 120. But I'm not advertising any information. All right. With that being said, what we're going to do is we're going to take a break. Let's just walk away for a little bit and think about it. You might want to go back and look at some of the lecture components and see if we can't figure out exactly what's happening here. But bear in mind, we're going to be using DMVPN in a lot of our deployments. So it's going to be important that we understand exactly how the routing protocol is going to operate across that particular configuration. And also keep in mind that RIP is not as granular as we would like it to be. So I'll see you guys after you get your break. And what we'll do is we'll come back and we'll talk about this some more. Bye-bye.